In this video, generate the Touchard polynomial from 0 to 8 degree. So our value for k will be data validation over the range 0 to 8 and save this. So we can start at 0. Next we continue with the expansion, which is e to the minus x times the summation of n raised to the power k over n factorial times x to the n, where the value of n is from 1 to infinity. And the value of a, which is n raised to the power k over n factorial. So array formula of n raised to the power k divided by, that's for the numerator, divided by factorial n. So factorial n. Now we can complete the series sum expansion. Array formula. Series sum of the x values raised to the power n, where n starts from 1 to infinity. So 1 incremented by 1. And the coefficient a will be this range. And we'll chart this. Insert chart. And we use scatter chart. Row 1 as header. And show the trend line from the series. The trend line. The type, polynomial. The degree, 8. And for the label, use the equation. For the legend, position at the bottom. So here's our trend line and polynomial. We continue, we factor in e to the minus x. So we multiply this again by, that's times e to the minus x exponent of negative x. That's e to the minus x. This is the portion here. And we chart this. We have the chart, so we calculate the polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, which is array formula of the x values raised to the power 0 to 8, and we use LINEST. This would be LINEST data y and data x. And you will notice these values here is copied to the value of b. So we increase that, we increase the value of k to 1. These values are copied to b. Increase this to 2. These values are copied to b. Increase this to 3. These values are copied to b. Now we continue with the Touchard polynomial, which is array for the series sum of the x values raised to the power n, or where our exponent will be from 0 to 8. So 0, starting from 0, incremented by 1. And the coefficient from here to here. And enter. Their values are exactly the same. We'll show the polynomial regression coefficients from the series, the trend line, and the type polynomial, the degree 8, and for the label, use the equation. So here you have the equations. there's a bit of difference here. There's a slight error, but this is 1, 1, 1, 3, 1, and 0. So this is 1, 2, and 0. And we use LINEST to calculate the ones in blue, the Touchard polynomial. So that is LINEST, data y, and data x. Their values are the same. So we can start from 1, from 0. That's x. We continue with k equals 1. Also x. That's x. K equals 2. That's x plus x squared. So x plus x squared. K equals 3. We have x plus 3x squared plus x cubed. So x plus 3x squared plus x cubed. Same thing with 4. That's x plus 7x squared plus 6x cubed plus 1x to the 4th. So x plus 7x squared plus 6x cubed plus 1x to the 4th. The rest are 0. K equals 5. So we have here x plus 15x squared plus 25x cubed plus 10x to the 4th plus 1x to the 5th, x to the 5. K equals 6. So x plus 31x squared plus 90x cubed plus 65x to the 4th, 15x to the 5th, and x to the 6th. Likewise, we have the same. X plus 31x squared plus 90x cubed plus 65x to the 4th, 15x to the 5th, and x to the 6th. K equals 7. Here we have x plus 63x squared, 301x cubed, 350x to the 4th, 140x to the 5th, 21x to the 6th, 7x to the 1x to the 7th. Also, x plus 63x squared plus 301x cubed, 350x to the 4th, 140x to the 5th, 21x to the 6th, x to the 7th. And finally, k equals 8. So we have x plus 127x squared plus 966x cubed, 1701x to the 4th, 1050x to the 5th, 266x to the 6th, 28x to the 7th, and x to the 8. This completes the use of Maclaurin series sum minus polynomial regression to show the polynomials and trend line of Touchard polynomials.